Welcome to electron In this video, as well as the videos to come after this one, we're going to solve some one-dimensional problems in physics and mechanics. But in this case, instead of using the equations of kinematics, we're going to solve these problems using the graphical method. Remembering that we can draw an x versus t graph, a v versus t graph, and an a versus t graph. So, for example, x versus t, x is distance, t is time. We can also draw a v versus t graph, and we can draw an a versus t graph. Remember that in a v versus t graph, let's say this is it right here, this line would represent velocity, the slope of this line represents acceleration, and the area underneath the curve right here represents distance traveled. With an acceleration graph, we know that the slope represents a change in the acceleration, and the curve, the area underneath the curve, represents velocity traveled. And when we draw an x versus t graph, we know that the slope represents velocity, and the area underneath the curve doesn't really represent anything. But at least knowing that, we can actually solve a lot of physics problems using some clever techniques using the graphical method. So what we're going to do here is we have a problem. We have a car that travels at 75 kilometers per hour for 25 minutes. Stops for 10 minutes, then continues at 90 kilometers per hour for another 40 minutes. And the question is, how far did the car travel, and what was the average velocity of the car? Now, when I'm thinking about it, if I draw a v versus t graph, velocity versus time, the area underneath the curve represents distance traveled, and so therefore I could figure out the answer to the problem by calculating the area underneath the velocity versus time graph. So let's draw a velocity versus time graph. So here's the velocity versus time, and for the first 25 minutes we're traveling at 75 kilometers per hour. So here's 75 kilometers per hour for 25 minutes. So 25 minutes, convert that to hours, that would be 5/12 of an hour. So this is 5/12 of an hour. For that amount of time, we're traveling at 70 kilometers per hour. Then we stop for 10 minutes. So let me go ahead and write the 25 minutes here. So this is 25 minutes. This is 10 minutes. And let me move this over here as well, so it makes a little bit more sense. So this would be 5/12 of an hour. This is 10 minutes. That would be 2/12 or 1/6 of an hour. 1/6 of an hour. Or 2/12 of an hour. Maybe we'll keep it with the same fraction. So 2/12 of an hour. And then for the next 40 minutes, we now travel at 90 kilometers per hour. So that's a little faster, like this, for a time period of 40 minutes. So this is 40 minutes. And of course, 40 minutes, that's 2/3 of an hour. And if we multiply this times 4, that would be 8/12 of an hour. All right, there we go. Now, the area underneath this curve represents distance traveled. That would be the answer to part A of the question here, right? We want to know distance traveled. If this is area 1 and this is area 2, and remember that in a velocity versus time graph, the area underneath the curve does represent distance. So we can say that distance is equal to area 1 plus area 2. And area 1, that would be the width, which is 5/12 of an hour, times the height, which is 70 kilometers per hour. So that would be 5/12 of an hour, like this, times 70 kilometers per hour, plus the area of the second rectangle, that would be equal to 2/3 of an hour, 2/3 of an hour, multiply that times, that would be 90. Okay, I didn't write it on my graph here. I will do that. This would be 90 kilometers per hour for the height of the second triangle. So multiply this times 90 kilometers per hour. And now with a calculator, we can go ahead and work that out. So we have 70 times 5, that's 350 divided by 12, plus 2/3 of 9, that would be 60. So plus 60 equals, so that means the distance traveled would be 89.2 kilometers. So notice how nice that is to work it out graphically like that. Simply the area underneath the curve represents distance. Now, what is the average speed? The average speed would be, by definition, right, V average is equal to the distance, total distance divided by the time. And so that can be represented by probably a rectangle like this. I'm not sure if it'll be higher or lower than this, so maybe it's like this. So this rectangle here, not quite sure what the height is, would represent the speed at which the average speed that I travel at for the entire duration of the time. That would be 25 minutes plus 10, that's 35, plus 40, that's for 75 total minutes, which would be 1.25 hours. What would be the average velocity? So what we can do then is, this is equal to a total distance of 89.2 kilometers divided by a total of 1.25 hours. So we take that answer, divide by 1.25, and we get 71.33. 71.3 by 3, that would be kilometers per hour. Which is, wow, I was almost right on with my dashed line. That would be right here. That would be 71.3 kilometers per hour. So graphically, we can see that this here would be the average velocity for the whole trip, which is simply the total distance traveled, 89.2 kilometers, divided by the total time taken, a total of 75 minutes, which is 1 hour and a quarter of an hour. We divide 89 by 1.25, we get 71.3. So this graph right here represents the average velocity, and the area underneath that graph is simply equal to the area of A1 plus A2, the total distance traveled. So graphically, it can be done in this fashion.